A chemical bond is nothing but a force. It's a force that holds group of atoms together and make them behave as one unit. Now, you should also know at this stage, if you break a chemical bond, you need energy, and that's known as endothermic. It makes sense. To break a bond, you need energy. The opposite now should be true. If a chemical bond is formed, it should give you back energy, so it releases energy, and that's known as exothermic. We are also going to introduce a new vocabulary known as electronegativity. I'm giving it a symbol of capital E, capital N, and I'm defining it as measures the pull of an atom for the shared electrons in a chemical bond. It has been defined many different ways, but it's just a sort of a gauge for how strong an atom is pulling the shared electrons toward itself. Now, if you look at your periodic table, fluorine, and if you look at a periodic table that has electronegativity value, has 4.0. So this is electronegativity of fluorine, and we call fluorine the most electronegative. The most electronegative. So that means fluorine has the strongest pull for the shared electrons compared to other elements. Now, on the same periodic table, if you come to group 1, the period 6, I'm going after cesium, and that is on a scale of electronegativity is 0.8, and cesium is known as the least electronegative, meaning cesium really does not like to pull the electrons toward itself. It's pushing them away. Also, cesium sometimes is called the most electropositive. Electropositive. Now, if you look at your periodic table really carefully and look at all these numbers, electronegativity increases as you go up a group. Also, if you look at the period as you go across from left to right, as you go from metals to non-metals, electronegativity increases. Sometimes we refer to as a diagonal rule. So from cesium to fluorine, you should just remember sort of as you go up and as you go across, electronegativity increases. That's one thing we should realize at this stage. Electronegativity increases. So you should also realize that nonmetals, which are here, have a larger electronegativity than metals, which are on the left-hand side of the periodic table. So metals are electropositive, nonmetals are electronegative. And all we have introduced this here is a scale to gauge how strong these elements are pulling the shared electrons toward themselves.